You have noticed that I'll talk about and flood management activities, initiatives in Bangladesh, and well, it will focus on, but I mean surface water, but not deeply about the wastewater, because it has been covered so much, and as per request of our Dr. Hossain, I am trying to focus on it. So next one, please. You can see some of the pictures shows flooding scenarios. Next, please. And you know, geographically Bangladesh is here. It means the Himalayas, Great Himalayas, I would say, and the big river system, the Ganges, the Brahmaputra, and Meghna, they all, next please, yeah, they all discharges into the Bay of Bengal, right through the heart of Bangladesh. Here from the west, the Ganges flow comes, from the north, the Brahmaputra flow comes, and from the east, the Meghna and the Meghna systems flow comes. So that is the main tragedy of flooding in Bangladesh. There is no way to control it, but there are ways to manage it with the support from the regional countries. Now, Bangladesh, land of rivers, and also land of floods, I would say. Not only these border 54 rivers that enters Bangladesh from upstream country, India, as the location of Bangladesh, you have seen, it is right within the territorial domain of India. So there is no way to deny that, and there is no way to avoid that. There are many river systems, but the major river system, they enters into Bangladesh from India. There are 3 small rivers that enters into Bangladesh from Myanmar, but they have actually no significant impacts on flooding in Bangladesh. Next, please. And you see some of the values within Bangladesh. Brahmaputra River, you can see the discharge, you can see other water level and other things, and the Ganges also. See the maximum discharge values. They are really noteworthy. But the problem is this maximum value occurs in July, August, not other times. So the minimum value that occurs, we have total flooding period 5 months, and total non-flooding period, that is dry period, is 5 months, 7 months. So total internal river is 310, it's fine, but those internal rivers are fed by the water of the 54 plus 3 perennial rivers. So that's, many of you know here, I know, but many of you even do not know. That's why I'm mentioning it. And these dotted are, as said, they are the border rivers. Next, please. Now, water is the essential part of the life and livelihood in Bangladesh. Naturally it is. And also, at times, it's a source of hazards, hardship and disasters. Now it will follow. And the background photos always show the 5 months flood actually prolongs. Although there are no rainfall, but because of the drainage situation, it's a very flat land. And the sea, Bay of Bengal, if there is fluctuation there, the Bay of Bengal is the terminus of all the waters and sediment flow of this river system. So if there is some fluctuations there, even due to tidal or due to sea level rise, there is problems. Our coastal region faces this, drainage congestion severe. I'll talk about that. So I have already said it, monsoon and non-monsoon period, and also pollution of surface water, and in some areas groundwater. And because in the coastal areas there is no fresh water, so groundwater pumping is taking place, and the salinity intrusion into the soil mass, and groundwater level is taking place. So I will not talk much about that because I will keep concentrated on the flooding. Next, please. Now, population. It has to be mentioned. Population is major driver for many things in Bangladesh. And Bangladesh is a small country, but highly populous country. It has an area of about 147, say 150,000 square kilometer. But it has a current population is more than 160 million, making the current population density 1200 per square kilometer. Not really comparable with any country of the region as well as any country of the world. And the projected population, the way it is increasing, in 2030 and 2050 projections are given. And many people are moving towards urban areas from the rural areas because of, they need first their livelihood survival, then their shelter, work, many things. So what happens at this period, the population of city areas and urban areas will equalize. Total population I am not showing. If you add them up, that will be total population. So in 2025, the population will be more than 220 million. And 2050, population will increase. And in 2100, because currently Bangladesh Delta Plan 2100 is ongoing, and many of you know that is being done with support from Dutch government. They are projecting everything, but they are not rightly projecting the population at that time. So there is some lapses in all the initiatives. I am not going to criticize our own programs because our government people are involved there. So that is going to put another problem. Next, please. We go move forward. Flood resilience in Bangladesh is one point. Many government people used to say that we are a flood resilient country. Maybe when you are compelled to comply with certain situations, of course you are resilient, but at what cost? If you compare, well, you are living, you are laughing, you are doing everything, but in a shanty house, in a muddy road, and with in remote areas, no water supply sanitation, but still you are surviving because there are supports from the government as well as from the international donors. And still, some people are happy, some people are unhappy. These things. And I'm not talking about it, already done. Next, please. Now, causes of flood. Already somehow it has been said that first of all, the unique geographical location. All water has to discharge into the Bay of Bengal. Rivers that originates from the Himalayan region or just Himalayan. So that is the main cause. Then comes other causes. Excess runoff. So main flood comes from the major rivers, but there are rainfall also there. We have about on average 2200 millimeter of rainfall annually, but 80% or 90% of that 2200 millimeter happens in a short duration, 5 months. But the 3 months is critical, June, July, August. So heavy rainfall, and rainfall occurs due to depression in the Bay of Bengal. The cyclone surge may come, another flood may come. During that period, to draw a line in this line, accepting, just avoiding these higher areas. These areas are underwater for a significant period of time. Next, please. So these are some of the statistics summarized, that every year 20% of our cultivable land are flooded, but in extra severe flood situation, up to 65, even 70% of the country's areas are flooded for a duration of 1 to 2 months. You know what kind of damage can happen during that period. Next, please. And these are some of the data, I would say, water level data, and some danger level is given, and how many times it goes above danger level. This is some data. Next please. So this is Jamuna River at Bahadurabad, Ganges River at Hardin, Padma River at Bhagopur. Many of you know these places. Next please. And this is again floods in Bangladesh. And these are some again statistics. I think I have given my presentation in presentation format. You can collect all these things from there. And you can extract data from it also for your analysis if you want to do in your own way. Next please. These are some rivers data. These are all data. We collect data. Bangladesh Water Development Board and IWM also collects data. And we do a lot of activities. We play with this data. We have models, various kinds of models we generate. And we also, the data gaps are filled up from the model results. Next please. So this is some of the area. Yes, you can see that. Next, please move ahead. Yes. Because some years, the major flood we have shown. You see this year, flood affected area, almost 1998 flood in Bangladesh. About 70% of the country was flooded. And a lot of devastation took place. And also the duration of the flood water, it took 2 months to drain out the flood water. So that's why the major flooding years are shown here. Next please. And this is a percentage area affected by floods since 1954. And the last one is 2014 flood. And the 2017 one, another large flood. The rough estimate is 40% flooded of our country. The source is Bangladesh water source. Next please. So yeah, okay. During major historical flood, these are all data. It can help you preparing your term paper, research paper, and sometimes research ideas we can develop. Next please. Just pictorial view of some of the major floods. 2004, you can see Dhaka city and Shanti area. I mean the outskirts of Dhaka. Well, pumping house. Pump cannot really pump out because the Dhaka city itself is, it is embanked, bouldered, and that has created another problem because due to insufficient pumping capacity. When bouldering was done on the Dhaka city, from the suggestion of the donor communities and the donor experts, they considered pumping, but very insufficient. Only 20% water can be pumped out. So it's a big problem. This is Motisil area, business hub of Dhaka city. Next please. Flood 2007 is the last flood. Next please. Well, next please. Yes. Next. Well, these are coastal flood highlights. Next please. Flood embankment is the general practice in Bangladesh. Bangladesh learned it from India because, Indian book on flood control and management by K.L. Rao and so many professors. We have our own manual, but we try to compare. And you see, it's a road, but the flood has done something. Next, please. And effects of flood, pollution, polluted water. Flood water is, well, you all can imagine what are these. These are effects. And, well, people has no place to go on the embankment. And when the embankment goes underwater or damage occurs, then it's a big problem. And flood does a lot of damage to crops, croplands. And not only homestead, but also, next please. And coastal flood is one of our major floods. We have identified that because of our upland flood, we have a cooperation. At least 1, 2, 3 points data we get, and we can give some warning with some lead time. And the cooperation, one cooperation is with India, because these were two rivers, and one cooperation, 1 or 2 points with China, because flood comes from far away also. Well, those are used for validation of our model, that how correctly they corroborate. But because of the gap of information, sometimes the model results are reliable, and sometimes they are a little less reliable. So, well, coastal floods could be due to many reasons. Next, please. The next one. Now these are photos of some coastal. Next one. Now. And coastal area digital elevation models we have prepared, and it shows that our coastal area is about 30% of the land area of Bangladesh, and whose elevation is given here. So you have the copy of the presentation, you can have a look at it, critically look at it, because you may not see very clearly here, but on your computer you will be able to see it very clearly. And you know, 1 meter sea level rise predicted. If it happens, hope it will not happen. So about 25% of the area will go permanently underwater and saline water in 2100. So what will happen to the people of that? What will happen to the soil characteristics, their food production characteristics, fishing industry, what has been established there? We are not aware of it. But something has to be done. Some models has been well developed, but models need reliable data to validate and also verify. Next, please. And cyclone is a recurring effect. I have only shown the last one in 2001, cyclone Ruan, and the damage. And the last one was in fact in 2017, but it hit Myanmar. But the 2016 one, you see, go back just one slide back. You see around Indian coast, but it did not hit any coast here. It originates somewhere here, it goes follow the coast and hit Bangladesh. So that's, as I said, the cyclone prediction is very difficult. We have tried our best. We have a division, Coast, Port and Estuary Management Division in IWL, they are trying, but it's very difficult to say. Next, please. Next. Yeah. These are some of the coastal floods that hit Bangladesh over the last few years. Next, please. And here is the list. Years and where it hit and total death. But death toll is because human casualty. There are also cattle casualties, other homestead, animal casualties, and also damage of crops and everything. Next, please. So these are some of the predicted area at 25-year or 50-year or 100-year return period. We have exercised our modeling activity in Bangladesh. Of course, this task are given by the government. IWM being a government established institute, so government gives us a lot of tasks to do. Next, please. And so these are maps. You will see it in the diagram. When you click, you will see 25 years return period coverage. Next click, you will see 50 years return period coverage. Then next click will give you 100-year return period coverage. You can try other years in between or beyond 100 years what might have happened using your own model. You can also test your model against this model because these are all MITE system, They are commercial packages and they are very expensive because the royalty that we need to pay to DSI is in our currency about 1 crore Dhaka per year. So the total model price is very high. Next, please. So this is we have boulder system. And the present boulder system was designed to withstand 10-year storm surge in 1970. That was also designed by foreign consultant, mostly Dutch and European consultant. But the result is that no boulders is effective against storm surge, because that is not storm surge. Nowadays, frequency of storm surge has increased. Next, please. This is some of the activities what we did is, impact of climate change, what happens. Some 1998 flooding scenario, what happened, and if this flood occurs in 2100, what will be the scenarios in Bangladesh? These red areas are permanently, because the digital model elevations are different at different places, will be permanently underwater. You can test this with your own model and make a comparison and submit it to your boss to see. Because these are points which will stimulate you to do more research. And Bangladesh is nothing but very neighboring country of India. So we should collaborate and work and see what happens. Next, please. Now, people are talking nowadays about climate resilience, coastal boulders or embankment. But the thing is that, is it climate resilient? No, but at least this is not a 10-year return period embankment. So this is the existing yellow one, is existing one, and if we want to make it to withstand 25-year return period, storm surge, of course, storm surge, you can go for 50 years, but it will be so expensive that, well, it cannot be built even with donor money. This is the height, because in an embankment, you need to have many kinds of additive value, not only level, but enough wave height and other things. So this much of land has to be, acquired. And land is so valuable in our country. There is no place where there is no people. So displacement of population and acquiring this land is something next to impossible. But still, for moving forward, we need to do sometimes, and the project become very expensive. That's why in the paper it is written, the road project and the embankment project in Bangladesh is more expensive than even in Europe. Not to talk about India or Myanmar or other country, only because of land values and the people who has already settlements there. Next, please. So flood mitigation so far, initiative taken based on these two classes of mitigation measures, structural measures and non-structural measures. Structural measures is mostly embankment and hydraulic structure. Only embankment will not resolve anything. You have to keep a lot of opening, because flood is a problem, drainage is associated problem along with flood. And non-structural flood forecasting and their dissemination, and also flood preparedness. Because if we know that flood is coming 5 days ahead, that's one kind of preparation. If we know flood is coming 3 days ahead, that's another kind of preparation. And if we know flood is coming after 6 hours or 10 hours, like the flash flood of 2017 in Sylhet Basin from Assam, it came. That's something. All crops were damaged. So government is now giving a kind of relief, which is not acceptable to the people. They said, we don't want relief. We want what? We want our protection, and we want what? And we want our children to go to the school, universities, and everybody, not sitting idle. So that's a part of life, So, well, but mathematical modeling is playing a great role, and that's why the next few slides will be about that. Next, please. So, structural measures, you see what happens to the faith, and cyclone shelter, flood shelter, we have a number, but not sufficient. Well, This is flood protection, 10,000 kilometers. The river flood protection. But we have coastal embankment, another 10,000 kilometers. So total makes 20,000 kilometers for a small country like Bangladesh. So in India, I do not know how many kilometers of flood embankment you have. I cannot imagine. India could be 50 times bigger than Bangladesh. Anyway, next please. So improved flood management came. Previously in our country, flood control term was very much popular. Now we have seen we cannot control flood, rather flood control human. So we forgot that term, let it go, and flood management. Now we are trying using support from modeling tools and other people. Previously engineers were engaged, now economists, the biodiversity expert, ecologists, and the social experts, all are put together to work against flood risk, vulnerability, their mapping and everything. But modeling is helping to do a lot of activities mentioned here. Next please. So summary of activities and achievement, well, it's written. At least flood forecasting and warning has been improved so much with support from regional countries. We get data from Ganges Basin, but 3 points. We get data from Brahmaputra Basin, 2 points from India, 1 point from China. We also get only 1 point in Surma Basin, Surma Barak Basin we call it. But it is helping because the model is there, and so it is helping to give some kind of forecast. And city problem and our dissemination is through government bodies, and we have some web-based and some mobile-based dissemination with community support, stakeholder support. So the network is very good, I would say, but the magnitude is so much, only we can reduce damages. We cannot really obviate or get ourselves free from those kind of natural calamity or disaster. Flood is the largest disaster for our country. And improved city drainage and flood management is highly essential. We are working on it. So adaptation for our country, given its location and given the magnitude and given the future climate change scenario, adaptation is really always said by the government, because we have nothing to do about mitigation, the root causes where it should be emphasized. But anyway, we have to adapt, because poor people has nothing to do but to adapt. If you do not have food in one time, you have to adapt to it like that. Anyway, next. So coastal system mangrove afforestation is very important, because Sundarban is a World Heritage there, which is shared by both Bangladesh and India, but still there is a lot of problems in those areas. Next please. And one thing, go back, you will see some of the charts. These charts are very important. It is not visible perhaps because of the, beamer, the beamer quality. I mean the machine that is projecting, it cannot really show this. It happens how afforestation can help. Next please. It's okay if you don't show it, you can see in your own lab. So how it helps, I would say, withstanding or reducing the storm surge height and affecting the coastal area. It's the model desert. These are all model deserts. Move please. Move on. Now, raising of embankment. This is one of the raised embankment in the coastal area. Right side you can see water and water and water. On the left side, protected area. But how many areas Bangladesh can afford to protect in this way by raising the embankment? That's a big question. Next please. Next. Now, these are again activity, some results what IWM is doing and giving to government in water levels and what forecasting. different areas. We have water level measurement stations all over the country. We have also discharge measurement stations, but not in number, not comparable with water level station, because they are very easy to install and they are very easy to have a benchmark. But the discharge measurement for a large river system is really difficult. Anyway, digital methods are coming, and high level of equipments are being procured, so measurement can also be done. Next, please. Now, what we do, we are showing different kinds of models we use for flood forecasting. Ganges Brahmaputra Meghna basin model, we call it. Since the basin is very large, so we start from Himalaya, Everest, and we go to the Bay of Bengal and to some extent Indian Ocean. We pick a big area, very crude resolution, then we make it smaller, then we make it still smaller, 600 meter by 600 meter grid. Then we have some generalized model, then we have Bay of Bengal model, we have all regional models, and we have everything, and finally we get some result, and the result is compared with field data. Next please. So we have prepared plus hazard map, 25-year return period. Next. So this is 50-year return period and the area changes. Next please. Yeah, then 100-year return period. Because we think that our country will not face floods more than 100-year return period. It is the belief nowadays, but climate change will really make changes to rainfall pattern and also the flow pattern and also sea level changes. So, well, I do not know whether this has to be changed. Like the Dutch, they have 10,000 year return period flooding, mapping of the country. And they build embankment, the current one is 1250 year return period, and they are contemplating to change some of their embankment in some places, not all places, on the Holland area maybe, not the whole Netherlands, to raise it to 10,000 years. But we cannot dream because none of our embankment height is 100 years. We are just developing scenario to tell the government, to give the message that what you should have in your mind. Next please. So these are percentages of inundation area, well, division-wise. Our country is small, but it is also divided in various. Next, please. So these are some model generated result, and and the satellite one, because we have, geospatial information we have. So there is a good opportunity to compare. Next, please. So these are next page. Next. This is because we have a disaster ministry and they wanted some flood hazard map. So we did it with Department of Disaster Management. But anyway, I must say that AIT and Thailand also was with us. Next please. So flood forecast coverage, not the whole country is covered. You see next one, this part, flood, this part is not covered. Separate and storm surge area part is also not covered because it is very hard to really forecast in those areas. Next please. So flood forecasting and warning system in Bangladesh. This is a great detail in depth. It is given there. You can read where we start from data collection and then up to flood forecasting. And the system is housed in Bangladesh Water Development Board, but the main support is provided by IWM, and Water Board has a flood forecasting and warning cell. The work combined. Next please. So these are again repetition of things, but anyway. These are some of the flooding here, large floods covered, and their forecast efficiencies given. It's a non-structural measure, but it helps a lot because the return from non-structural measure is higher than the return from the structural measures. In one flood, the structures may be damaged and the whole lot of money, huge money invested can be washed out. But forecasting warning is always there and it helps a lot, saving not only lives but properties and economic damages. Next please. So, we are working 7 days on test basis, but 5-day forecast is there. Next please. So, where we are doing that? Next please. And so, recently we are working here. Already we have worked by using JSON 2 data from NASA. And we have a joint project with the American University. And we have partners from ISIMO. And well, you know, I don't want to tell detail, but there are some data generated in upstream from the satellite data. We compare it only with 2 field level data that we get from India. So some reliable results are coming up. Next please. Next. Where we are really applying it. And where are the pseudo situations and the real situations in different river basins, it is shown here. In Ganges, 4 station, in Rome, 2 station, and in Yamuna, 2 stations. Next please. So the correlations are quite promising. I would not say that's satisfactory, but it gives a kind of promising results. So we can continue it. Next please. Yeah, forecast in 9 stations. And the forecast period is longer than the traditional forecast period in lead time, I would say. Next please. Yeah. So these are some where we got good correlations because it has to be compared with field data. Next please. Well, these are again results and compared because we are using satellite data but using our model which also covers the whole basin. Next please. Yes, Ganges okay, Rome okay. Next please. So 8 days forecast is planned because if you have, well, Bangladesh people has no place to go, but at least they know their mindset, their peace of mind is there. They know they are staying, they cannot leave their house with a living bag behind their property, small property, and you know, goat, cow, or whatever they have attributes. They don't want to go out, but still they are mental. Next please. Next please. And benefit, I have already said, forecasting benefit is much more than real investment, field level investment benefit in terms of structural measures. Next please. Next. Next. Yeah. So this, what we are planning that other basins we can try. And area of coverage will be extended, more population will be benefited. Next please. So flood resilience measures, what I discussed is summarized here. But we need to add something more. As I was discussing, flood measures is not really flood measures. It should also include other things inside. Next please. So this is my last remarks that Bangladesh is a very small part of the larger hydrodynamic system that comprises several countries in the region. I have already said India, the major one, the next one, but we have Nepal because the contribution comes. In Brahmaputra system, contribution comes from Bhutan also and China also. So, co-riparian cooperation is essential, at least for study and research purposes. And also, this will help in the long term for Bangladesh to have sustainable living standard as well as sustainable development. Well, thank you very much for your patient sharing.
Thank you, sir.